So, AAM stands for Australian Aerial Mapping. Now, it's a bit of an old name, and that's hence why they've changed it to AAM. But they first came into prominence 40 years ago or so, supplying high detailed photography, aerial photography for arid remote areas, or back then sort of mining prospects, road mapping, large, with the I guess the tyranny of distance of Australia, areas that were almost inaccessible to get to with traditional surveying. So they were for bleeding edge back then, owning their own planes and basically creating some of this technology as they went. Fast forward now to the era of BIM, and they're also leading edge, looking at some of the capturing technologies that exist now to turn built environments and built structures into a BIM workflow and utilise some of the analysis tools and some of the system tools and information gathering tools that BIM allows for. So quite happy to have joined them just recently, and the connection through this presentation then was quite good, because you'll see from some of the information that's on display and what I'll go through in the presentation, and certainly from what RedStack and Imagine IT have done, is recognise that very early on and allowed for this workflow from existing buildings back into a BIM. And I think that's probably the best way to term it. We've started to call it reality capture. A lot of people, there's a few more acronyms now in this world that I'm even learning still. So HDS for high definition scanning and high definition surveys, and you've got terrestrial versus LiDAR versus a whole heap of acronyms. I thought I'd finish learning them. You never do. But if we just say reality capture and digitalisation, so to digitally capture a building or a plant or a stadium or any sort of asset, and then convert that into something that you can utilise and analyse, like in Sapphira's case. This is a program called Autodesk Recap, and what it does is allows us to bring that scan into tools which I'd say now the layperson can use. Some of this technology was quite engineering and quite difficult to deal with, and although this mouse is giving me a little bit of grief, we'll persist on. Yeah, so no guesses or no prizes, unfortunately, although there are plenty of balsa wood planes to go around. But this is a point cloud scan of the Geelong Town Hall. Now, you might think that it's slightly pixelated, and you'd be correct in that. This actually was done, as I said, about 3 years ago, prior to some of the new machines coming on the market, and AAM have the newest ones on the market, which are crazily good in resolution. But even still, this gives you a good indication of the built surfaces that are there, all of the features that you would look for if you were doing a extension or renovation. And of course, I've just heard in the news that you've got a library that's being put onto the back of this, so that should be amazing, and hopefully we'll get to do another scan again, which is more higher resolution. But the ability of using this sort of data and connecting information to the actual geometry that was there at the time, and you can see some people in this case. If you wondered what happens when people walk past, well, it's a little bit like a photo bomb, except it's a scan bomb. And I'll just use the fly tool, hopefully. So the scan actually will capture the movement in some cases, so you might see 3 or 4 outlines of people who are walking past at the time. What actually happens if before I go inside the building, if I just zoom back, and I don't actually have the image, go to the top, and we'll orbit this around for a second. Wow, this is a bit crazy. Okay. You might not be able to see in this actual scan, but this was actually put together, and Tim was on site when this happened. Can you remember offhand how many scans that? 86 or so. Yeah, that's what I thought. So obviously, with the scanner as it is, one scan's not enough. Unfortunately, it'd be great if it was. It doesn't see through walls. Well, some can do a bit of thermal imaging. But so you need multiple scans to be able to capture. So what the technology does, which is fantastic, is it remembers and figures out where all those scanner locations are. In the case of this one, while we've got actually some good height, you might remember, or you might know, there's a car park across the road, about 4 floors. So we took some scans from the top of that as well. And then it stitches all of those point clouds together. It through a registration process, it removes the extra bits or the extra dots that you don't need, a little bit like a JPEG compressors or a zip file, and it makes it into something that's actually a workable solution. Now, in this case, if I go straight to top and zoom in, you might be able to figure out that when we came on site to do the scanning here, we did scans around the edge. In fact, those dots are probably where the jigger or the unit was positioned, because obviously it can't quite see down, and you end up with a bit of a shadow. And then the surveyor who came down to do this for us actually went inside the hall. So you'll see that the blank spots is the rooms that we didn't get to, and in this case I think it took about 2 hours perhaps, maybe 2 and a bit. So it wasn't an exhaustive scan by any stretch, but it was show proof of concept, exterior facade, and then we went inside into this lobby area. So now that those clouds have been stitched together, we should be able to go into the building. My navigation skills will be tested. Let's go to zoom. Let's go to maybe look. And let's go inside. So if it looks like a little bit of a first-person Xbox game, you wouldn't be too far from the truth. A lot of the game developers are actually using this technology to scan race courses, to scan buildings, to Grand Prix tracks, and all that sort of thing to make their games even more realistic. So you might be able to tell that on this particular day of the scan there was a little bit of an art exhibition in. And again, this was only, it was a busy time, I believe, so we didn't spend too long in the actual capturing process, but enough to understand the concept of the staircase that's there, the counters, the location, in this case, of the artwork. And at that resolution for that time, that was a pretty good capture. That now can be taken into programs such as Revit, such as some of the other geometry tools. Bentley have their AAM product, which allows for integration with point tools as well. And this can form the basis of a model that might be brought into a BIM environment and either extended to or reworked. To bring this into Revit, there's a few tool sets we can use. So Revit natively now, since 2012 version, but certainly improved in 13 and now 14, has had the ability to import point clouds. So just through the insert point cloud option, and you'll see there's a list of point cloud types. Not a huge amount, but certainly some standard ways that would bring in point clouds or convert to this point cloud. What the Scan to BIM tool does is basically extend that. Once that point cloud's inside Revit, in reality that's about as much as you can do. So you use it to sort of model around or model over. The Scan to BIM tool allows you to do a lot more. So for instance, this is the scan of that same Geelong Town Hall. I'll just use my middle mouse, there it is. You'll see that at this stage has come in. Now this back in the day, this was a black and white scan. The new scanners, which AAM have, are colour scanners. So the overlay, I guess, is probably the other way to call it, or the colour indication that you saw before in recap, is just as simple as changing to this, which is now elevation, or I might do intensity actually. Probably should have the similar sort of colour scheme, maybe not. Normals. Just thinking about it. But it was basically a grayscale, so points of grey, 256. Now with true colour scanners, you can actually use those to capture an image as well as a scan at the same time and overlay into something that Leica calls True View. So it's like having your own Google Map or Google Street. You can go around the building and look up and down and around. It's quite amazing. In this particular case, as I said, because it's a few years old now, this comes in as default as grayscale. What that means is when you're zooming into areas and doing sections and cuts, it can be a little bit difficult to pick up some of the feature sets unless you get right in close. But still, that's pretty good. And that would allow us to actually start modelling, in this case, the columns. We have architecture students in the room still? So another Bolsterwood prize for telling me what the column is. Oh, I like that. Was a guess. I can't remember Corinthians, so I'll go with that. Ionic. Look, that's a very good detail for us to then start documenting in either heritage survey overlays and those sort of things. Bearing in mind, this scan's a couple of years old now, it's actually better. I mean, these dots, I think was from what's called a C10. A P20 is giving us 3 times or 4 times the resolution, which is probably over resolution, but there you go. We can go into our 3D tool, which is hiding from me. So I'll go down here. And we can use the section box, which is available in Revit as well. Section box. And this is available in some tools versus Recap as well. Cut down the point tool, start having a look at some of the areas inside. Struggling with this mouse a bit, but we'll get there. There's that staircase. Now, there we go, inside here. But some of the views and things you would use this for are a bit rudimentary, so we can start adding in some ideas of colorization. We could start adding in some different cut boxes and section boxes to the point that we get to one I prepared earlier, which is if I go to a window, to this one. So this is a scan, and if I go to one that hopefully has the whole scan, this is a scan of an existing plant room. Again, this is being done because maybe it's hard to access the plant room, or it's dangerous, or they just want an update of the assets they've got inside here. Again, this was done quite a quick process, so the gaps that you see here because it didn't meet the scope of where we needed to scan. So you're not always going to end up with the entire building. It depends on what the client's asking for or needing. And then we can start going through and looking at some of the extraction tools, which Scan to BIM and some other tools as well allow us to do. So if we go into a wireframe and turn off, there is some of the overlays, we can start seeing that these tools here will allow us to ascertain pipe runs and pipe sizes by clicking on certain surfaces. It will do a mathematical calculation of what's in that zone. It'll say, look, this is the tolerance that we're using. Can I verify it against a pipe type that I think it should be? And then it will start laying in the pipe over the point cloud that we'll then have to double check and match. It's looking for points, but I won't let it do it at this stage. It might be a little bit intensive. From there, we can start adding in to the pipe run that say the engineer is wanting to update. He can start doing some evaluations against plant equipment that he wants to replace it with. And if I go back and go to realistic colour, you see it in a better isolation with that point cloud as well. So it's all about turning those hard to capture areas and areas that you might not have any plans for back into a model environment that we can then start running analysis through, whether it's a Sapphire or analytical analysis or plugging into an existing BIM system like an MEP system to see the impact of those areas of the building.